job first algorithm. So this algorithm says that if there are many processes in a ready queue, okay, to select those process which has a less burst time, means those process which can complete in minimum time. Select those process. For example, if there are three processes A, B, C, let's assume that they are come at a zero time, okay, and their burst time is 100, 10, 10. Which process first selected? No, it's not A. It's selected get by B. B is selected first for 0 to 10 seconds. Then C is selected 20 seconds. Then A is selected 120 seconds. So what will happen here? Due to this, the turnaround time of the processor, turnaround time is 120 minus 0, 120. Okay. Here for A, B, 10 minus 0, 10, and is 20 minus 0, 20. It goes to 20 plus 20, 150, 150 divided by 3. It's 50 average waiting time. And average waiting time, what is? It's 120 minus 100. It will be 20. 10 minus 10, 0, and it's 10. It's 30 divided by 3. It's equal to 10 seconds. So you think that it is more better than first come first serve. But there is a very big problem in this algorithm. We will discuss in this. Okay. Let's assume that the same algorithm A, B, C. But now arrival timing of these algorithm is 0, 20, 20. So what will happen? Same algorithm. 0, which one is the first algorithm? A, because there will be no B and C coming at the 0 time. It will take 100, then B 110, then C 120. So now the waiting time and turnaround time will be 100 minus 0, 100, and it 110 minus 20, 90, 120 minus 20, 100, and waiting time will be of same algorithm, waiting time will be turnaround time minus burst time, 100 minus 100, 0, 20 minus 10, 90 minus 10, 80, 100 minus 10, 90. So now you see that the same shortage job algorithm face the similar problem what first come first serve face, that is starvation or convoy effect. That means if there is any one big process which come first, then the smaller process cannot proceed, and this is called starvation. But in shortage job first, we can solve this problem with the help of, that is called preemptive shortage job first. What this say? It says that if there is a algorithm which is running, if any process is running, okay, now if any other process come in the ready queue which is smaller burst time, then this process get terminated and this process get into the running state. Let know it with the example A, B, C. Three processes come at 0 second, 10 second, 10 second. Okay, then what will happen? First at 0, same process A process come for 10 seconds. Why? Because the burst time of A is 100, here it is 10 and 10. Now at the 10 second, B and C come, whose burst time is smaller. So what will happen? 0 to 10 A will running, and left 90 second is waiting. Now B will come and complete is at 20, C will come and complete at 30. Now the left portion of A will complete here up to 120 seconds. Now find the turnaround time. Turnaround time is 120 minus 0, 120. Here 20 minus 10, 10. Here 30 minus 10, 20. Now waiting time is turnaround time minus burst time, 120 minus 100, 20, 10 minus 10, 0, 20 minus 10, 10. Now find, it's 30 divided by 30, 10 second average waiting time, or here 120 minus plus 10 plus 20, 30 plus 150, divided by 3, which is 50 seconds. Okay, so by this example you see that what is preemptive first job, shortest job first, and what is non-preemptive. This is called non-preemptive, where one process is go inside a ready queue. Where one process is go inside a ready queue, it will not come. But in preemptive, if one process go, then it will come. So let's take two example. We first solve the same question with non-preemptive way, where one process is go will not come, and then again we will solve this question in preemptive way. So let's make a table with turnaround time, waiting time. So which process will get first? The process P4 get first, because P4 has a least, because P4 is the only process which is present at a 0 time and it takes 3 seconds, so it's P4. Now after 3 seconds, two processes come. P4 get completed, P1 and P3. Which has a burst time less? P1 is less time. So P1 is here for 6 seconds. It become 9. At 9 seconds, every process come. P2, P3 and P5. Okay. So which has a burst time lesser than anyone? It's P2. So P2 will come here. And it's 11 seconds. After which has a less burst time? It's P5. So P5 come for 4 seconds. Now P3 come for 8 seconds, 23. Now let's make the turnaround table. Turnaround time of this is 7, this is 6, this is 22, now 3 and 11. Turnaround time of P1 is 7, turnaround time of P2 is 6, turnaround time of P3 is 22, turnaround time of P4 is 3, turnaround time of P5 is 11. I hope you understand how we find the turnaround time. Now same question of waiting. Waiting here is 1 second, 4 second, 14 second, 0 second, 7 second. Okay. Now you see that here the average waiting time is 14 plus 7 plus 4 plus 1 is 26 divided by 5. Okay. How we find the waiting and turnaround time? I hope you remember. Turnaround time is exit time when the process exit minus arrival time. Okay. And waiting time is turnaround time minus burst time. Okay, so I take one example. P1 is exit at 9, okay, and arrive at 2, so 9 minus 2. P2 exit at 11 and arrive at 5, so 11 minus 5 is 6. Similarly we find that. And waiting time, turnaround time is 7, burst time is 6, so 1. Turnaround time is 6, burst time is 2, so 4. Similarly we find. Now we will solve the same question with preemptive base, not preemptive base. So how this question is solved with preemptive base? Let's assume. Make the table. Turnaround time here, waiting time. Same question, nothing difference. Okay. So what will happen here? Same question. First it is gone P4, because at 0 time there will be no process. So P4 is a first one process and it will run from 0 to 3 seconds. Why it is run from 0 to 3 seconds? It is because at 1 second the process which is come has a burst time more than P4. Process at 2 seconds come has a burst time more than P4, so it will run. After 3 seconds, how many processes come? It come P3 and P1. Which has a less time? P1. P1 will run, but each P1 run completely? No. Why? At 4th second P5 come, which has a less burst time than the P1, so it will run just for 1 second and remaining 5 seconds will be waiting. Now P5 will run and it will run for how much second? It will also run for 1 second. Why? Because at 5th second P2 come, which has a less burst time than P5, so it will run for 1 second and the left time 3 seconds will be here. Now P2 run for how much second? 7 seconds. Why? Because there will be no process come from P5 second to 7 second. And now which process will run? Please mark cross which process will get completed, so you will remember. Now there will be 3 processes left: P1, P5 and P3. Which has a burst time less? Here P5 has a burst time less because it is 3 seconds left, it is 5 seconds left and the P3 has a 8 seconds. To which process come first? P5, and it will complete after 10 seconds. Now which process? P1 and P3. P1 has a 5 second, P3 has a 8 second. P1 will complete it for 5 seconds, 15. Now P3 will be completed for remaining 8 seconds. Now using the same formula, we'll find the turnaround time. It will be a P1 completed at 15, come at 2 seconds. It will be a 13. Similarly, 2, 22, 3 and 6. Waiting time, turnaround time 13 minus 6, 7. Similarly 0, 14, 0, 2. Here find the average waiting time. Average waiting time is here 14 plus 7, 21 plus 2, 23. 23 divided by 5, which is less than the non-preemptive time. So I hope with this example you understand that there are two ways to solve the same question, preemptive and non-preemptive way. In preemptive way, we terminate the process, we stop the process when any process which has a less plus time come during that process. But in non-preemptive, we will not do this type of work. And there are two basic things. Why we are using non-preemptive way? We are using it because due to the starvation, which we have seen in the question here. Starvation. Due to the starvation, we have to do same thing. So I hope with these two examples you understand this concept. We will meet in the next video.